So hopefully we are live now. Okay. So yes, we are live on YouTube. And let me share my screen. You guys can see the screen?
Yep.
Okay.
Yep.
Now
I can.
I'm getting an echo.
Uh-oh.
Okay, let's see, where am I getting that from? Ah, it stopped now. Okay.
Drew, did the echo just start again?
Not for me, it kind of stopped for me.
Okay, because
are
I
you
went
getting
on.
an echo?
No. I'm frequently the cause of echo, so I went on mute for a second there, and you said it stopped, but I'm not on mute now, obviously, and well, maybe I'm not the cause for a change.
It's a little
Nalini?
weird, Mike. It's a little, I mean, I hear, I mean, it's kind of loud or something from when Mike puts his on. Or scratchy.
All right, I'll move a little further away. Is that any better? I'll talk softly.
Yeah, that's perfect.
So you're just basically saying I have a big mouth.
That's right. We're twins, Mike.
Okay, I'm getting a comment. The screen image is a little fuzzy. Okay, I think I did one setting, which might be the cost of that. So let me remove this and try again. I optimized for a video, but maybe that's the one which is causing the problem. So let's.
Bill Juris just said it's better.
Can you guys confirm? The screen looks okay? The voice is okay?
Everything's good to me.
I think, yep.
Okay, so we stopped the recording and just make sure that I don't forget to start it. Is it?
So yeah, we have a note in the chat room that it's okay for him as well.
Okay, perfect.
Is Suresh on?
Not yet, but I think he might join. No, but he's the first one, so of course he should be here.
Let me email Suresh.
I have his WhatsApp as well, so let me just send a quick.
Okay.
Hey Fred, hey Kathy, hey
Oh,
Nalini.
here he is.
Oh, there's
Hello,
Suresh.
hello, hello.
Hi, Suresh.
Hey, how
All
are
we
you?
had to do was talk about him.
Hey, it's 9:30.
We'll have to stop talking about him now because
I just got off a call with a client in Australia, so I just finished bang on time to switch on. So.
Perfect. So we have missing Jen. I think apart from that, we have everyone.
Excellent.
Okay, we have still people joining in, but I think we can start. I think I'll start my part, and by the time the main presentation starts, we will have enough crowd in. Is that okay, Nalini? Shall I start?
Yeah, sounds good. I'm just muting myself.
Nalini, do you think we should start?
Yes. Can you hear me?
Okay.
Hello?
Yeah.
Yeah.
Yes, I can
Yeah,
hear
you
you.
can hear me? Yeah. Okay. I'm going to go on mute.
Okay. Okay, guys. So we'll start our IPv6 track. Thanks for those folks in India. Early morning for you. Welcome. and late night, especially for Eastern time. Sorry about that, but I hope you find the session enjoyable and worth your time. So this is our IPv6 track. We have two set of talks first from Suresh and Mike, and then Suresh and Mike will also join Jen and Fred for a panel discussion. So looking forward for the next 2.5 hours of great IPv6 discussion. Request to our audience that use the Zoom Q&A when you have a question to ask one of the speakers or panelists. Please write it down clearly. These questions will be visible to all, so audience can always upvote questions, and that can also give us an idea of what people want to hear about. In an extreme case, if you would like to speak, you can also ask us in your comment that please unmute us, so I can unmute you and then you will be able to speak as well on need basis. When you ask question for the panel, you can mention if the question is directed to someone specific on the panel. Otherwise, I request panelists to click on answer live. That will mark that you want to answer this particular question. That also helps the moderator in figuring out who to ask audience questions. And as usual, please mute yourself when not speaking. Feel to use Zoom chat for all the other messagings. And I think now we have been doing this for a few months now, so most of us, I think, are well aware of the Zoom etiquettes. Okay, apart from the Zoom meetings, we also have a Zoom meeting link. This meeting link you can find on our link connections page on abstract and program. And this is the idea that, like, if you would like to socialize with other attendees or just to have a quick hi, it's been a while that we haven't seen each other face to face. So a good way to connect with folks. So use that link if you would like to socialize with people. And this will be live just after the programs ends today, as well as on every other day, pre and post event. We would like to, of course, thank our sponsors, Internet Society and Juniper Networks, for letting this thing happen. Internet Society has been supporting us for all iterations of connections, and Juniper has been supporting us for last 3. We are very, very grateful for them for their continued support. Stay in touch with us. We do connections every year. We do regular monthly events, both IISOC and INTC. If you would like to know more about IISOC and INTC, look at the recordings from yesterday, where we started with an introduction to both organizations and what we did. I will post these links again in the chat a little later so that you have these links handy. And I hope you would join our mailing list and WhatsApp groups, as well as our INTC programs. We do some really great events throughout the year. So to kick off the event, the first thing that we will do is a very special video message from Director General APNIC, Paul Wilson. APNIC has been very supportive of our activities, especially related to the IPv6 deployment. So we are grateful to have this video message played out. Let me play the video.
Hi everyone, I'm Paul Wilson from APNIC. Thanks for having APNIC here at Connections again, especially to our friends at the India Internet Engineering Society and the Industry Network Technology Council. I think it's hugely important to be bridging technology gaps around the world, and wider participation in internet standards development is definitely needed. So I want to start by congratulating you all on Connections in its 4th year, and also on this session about IPv6 deployment. APNIC is the IP address registry for the Asia Pacific, and that makes us responsible for the distribution and registration of IP addresses, v4 and v6, and ASNs. We were founded in 1993, not just to be an RAR, but also to take on that job in order to assist internet development in our region. And we've done that over the years through training and technical assistance and policy and advocacy work. We work for a global, open, stable and secure internet, which we believe is in the interests of internet users and the industry and society as a whole. APNIC's put a big focus on IPv6 over the years, as the only technology that can allow the internet to stay open and global and stable and secure into the future. IPv6 is a prerequisite for the future internet, and without it, the internet as we know it simply cannot keep growing. Without IPv6, the network will grow, but with huge constraints and lost opportunities, and it simply won't be the internet as we know it today. That future network without IPv6 would necessarily be less connected, less open and less global. So for instance, peer-to-peer applications like online video conferencing would always rely on intermediaries and overlays that add complexity and constraints and make innovations more difficult. Without IPv6, everyone would access the internet via private IP addresses and private services, without the openness and the capacity for innovation which has made the internet such a success. There's a myth around that IPv6 isn't ready or there's a ceiling to its deployment, but neither of those things is true. IPv6 is ready today to be deployed through every part of the internet and to bring immediate benefits. Around the world there are mobile networks, fixed line and cable networks, content distribution networks, and many other services which have fully deployed IPv6. And together they form an IPv6 internet which is around 25% of the entire global network. Between this current 25% and 100% in future, the only thing missing is action by too many people who don't quite understand the opportunity or haven't got around to doing the work. The world depends on the internet and the internet depends on IPv6. So if you depend on the internet, this goes for you too, and it's important to understand your own path to IPv6 deployment as part of your dependency on the net. You almost certainly don't need to rush to IPv6 today or even tomorrow, but you can, in the course of your business and your planning, make the transition at the right time when it will cost you little or nothing extra and it will bring you benefits. So I do hope this session of Connections shows you how possible that is, even today or tomorrow if you like, and it helps you to be ready and to make an easy transition as soon as the time is right. Thanks and all the best.
Thank you, Paul. That was a wonderful message. So let's start the IPv6 track. And we have Suresh kicking off the IPv6 with IPv6 on everything, everywhere. We are grateful to have Suresh speak at Connections. Suresh is the CTO at Kaloom, and his main contribution in the IPv6 area has been he was the AD of the internet area for twice from 2016 to 2020. During this time, he handled various IPv6 related working groups, 6man, 6low, IP-WAN, IP-Wave, all of these. And he had chaired various different working groups in the past. He has 35 RFCs, 40 patents. We are super grateful to have Suresh speak. And we have been trying to get Suresh to Connections since our very start. And it took a pandemic to get him here, but we are grateful to have him. So off to you, Suresh. I'll stop sharing and you can
Perfect.
take
Thank you.
control.
Yeah, thanks, Dhruv, and thanks, Nalini, for the invite. And yeah, it's it's just the timing never worked out. As as part of a startup, it becomes very difficult to find extra time to get over for an Asian hop, which already takes a bit of time. So I'm really glad for this chance to talk to the people, and again people Jen and Kathy and Fred and Michael. I think a lot of us have been I would say. In the same gang, right? Doing V6 for a while. And I just want to talk a little bit about where we came from a little bit, and also talk about where things are going, especially from what I've seen happening in the industry and in standardization, and where the future lies. So stop me at any time if you have any questions. I can talk into stuff. And Fred, Jen, Kathy, if you have anything to add, just feel free to add. As well, if you want to provide some perspective as well.
Suresh, we are waiting for you to share your screen as well.
Yeah, as I'm trying to do it,
Perfect.
Zoom. Yeah, thanks. I just had to quit for just a second. I'll come back.
I'll keep Suresh presentation ready just in case. Yes, Suresh, it's visible.
Perfect. Thank you. So who am I? Like Dhruv talked quite a bit about it. So I've been like another piece that kind of like I want to talk about is like I've been in the industry for 25 years, like not as long as a lot of the other people here. But I started my career at HCL Cisco in India. It's like a joint venture between HCL Tech and Cisco. And so like I've been doing like IP ever since. So quite a bit of time. And again, I come from like a really the IP background, and I started working on IPv6 probably like in 98 or 99. So it's almost like 2 decades of IPv6 work. And it has been like a very, I would say the first part of the 20 years has been very disheartening, right? Like, so it has been like a really, really slow start to the uptake of IPv6. And a lot of us like have been kind of like, kind of trudging on, trying to make a difference wherever we go, but things like really took like a long time to go. And also like I've also been like somebody who's been working on technology itself. So I worked on like a lot of RFCs, like drafts, IPv6 space, like both in like the protocol side as well as the operational side with Fred. And so one of the things that kind of really changed the IPv6 calculus is the invention of IPv6 into mobility, right? Like, so when I started working at Ericsson, like one of the things that we were kind of really pushing the world towards was to go towards IPv6, right? Like, and we did see quite a bit into the future where the mobile would become the predominant form of how people connect to the internet. And so like there was like one time I was actually talking to an operator when I was at Ericsson, and the operator kind of said, I said, okay, like what are you thinking about your V6 plans and so on? And they said, oh, V6 is a rounding error in our traffic, like, so don't bother, right? And that was kind of the attitude. Even like 10 years ago, a lot of people never put a lot of stock into IPv6. So it was more considered as either something to be taken care of as a check mark in an RFP, or something that you just had to put up with because like, you government requires compliance of you or so on, right? So it has never been something that was like really, really urgent to do. And if you start looking at it, like I can go back like quite a bit to 98, right? The number is going to be still very, very close to zero, right? And things are like, 0, 0.1, 0.2, and so on. And things are like pretty close to zero. So it was kind of like, the rounding error thing was like, I would say fairly accurate, right? And this is not because like people were not trying, like everybody was trying. So like, we had like implementations, multiple interoperable implementations, and we supported it in like mobile gateways and so on, but nothing really happened. And at some point, like if you look at somewhere around here, right? So like in sometime in mid 2012, like things started to change a bit. So like you see like the small uptake, and then you see this like, huge uptake, like where you actually see a sizable amount of IPv6 traffic, right? So what exactly happened here? So like most of the people who've been involved in this IPv6 community kind of know what happened here. So what happened is like, I think like going back to like what Paul said, right? Like, it's not like, you wait for something, you wait for IPv6 to get perfect or anything. All it was required was some action. And the action didn't happen because like we were caught in this vicious circle of like really who goes first. So what happened on this like one fine day in June in 2012 was there was this thing called World IPv6 launch that happened. So there's a bunch of people, kind of like everybody involved in this like IETF circle and the RAR circles got together and said, okay, let's try to fix like a flag day where we can actually turn on IPv6 and see what happens, right? So it was really like an adventurous like thing to start off with. And we got like a lot of awesome people who worked on this. Like too many people to name. If I start naming people, I'm sure I'll miss somebody out. But like if anybody who think, right, like, like Google, Facebook, Bing, Comcast, a whole bunch of companies and people, most of the people, Eric Klein, Lorenzo, Vince Cerf, and so on, and Brozowski, a whole bunch of people sat down and said, okay, let's turn this on. So it was really a concentrated effort, both on the content provider side and the ISP side. Because if this didn't happen, people are kind of just waiting around, right? Saying, okay, there's nobody to watch these things, and people said there's nothing to see, right? So that has always been the thing that was dragging down, the actual path to IPv6 deployment. And the incentives were really not there, because IPv6 caused more problems than it solved. Because a lot of in the developed world, what I would call the Western world, right? It had a lot of IPv4 space. So it was not really so much of a concern, right? And I had this at some point I was doing some research, right? I was doing some work for India and China, for Ericsson, to do looking at the address space, and I realized, right, HP as a company had more address space than India and China combined, right? And that was really because of the way the internet was kind of it grew, the address space was not really equally distributed. So there's some places where IPv6 became more necessary than the others. So people who have been connected to the internet for long have kind of been they're on a slower path to V6 than somebody who has really going through 2 layers of NAT or 3 layers of NAT. So things became a bit more urgent for those people. And that is kind of one angle into this, right? So the address space was really one of the angles into moving to IPv6. There's more, right? The connectivity between direct connectivity between people and getting back to the end-to-end model, and all those things were there. But at some point, the addressing became a sticking point. So this is what the IETF strategy was, right? And I'm guilty of the same strategy. We said, okay, dual stack is the best way to go, right? And everybody is going to have enough IPv4 addresses to stick along with the V6. And I've recommended this to pretty much everybody I spoke to, right? Get on V4, get on V6, and at some point we'll be able to take out V4, right? But it kind of became difficult. And if you cannot see, this dude here is Jean-Claude Van Damme. It's a big, action star. If you're an older dude, back in India, you couldn't have missed him, right? And so he was a very popular guy, and he's famous for doing a split. And this is actually a split he did on 2 moving trucks. So this is a Volvo commercial, right? So this is the kind of thing we had to do to make sure that dual stack was going on, because we were building 2 parallel infrastructures and kind of building a balancing act to make sure that things continue to work. And we started building more and more craft on top of it. We started doing stuff like happy eyeballs, because the IPv6 had a performance penalty, right? And so we were kind of racing V4 against V6 and see who wins, and started doing stuff. So we started building a bit of complexity to make sure the user experience was preserved. Because what would happen is, first of all, we started off saying, oh, V6 is always preferred. So even if V6 connectivity didn't work fine, or it was very slow, we would still go with V6. So the user experience suffered. So that's when we started doing this happy eyeballs kind of thing. But the real answer has been probably I didn't see it, right? Maybe other people might have seen it, but the answer might have been to probably pull off the band-aid and just go on, right, into V6. But we didn't do that. So we kind of believed dual stack will do it, but we kind of spent a long time doing the dual stack to make sure that we'll be able to transition, but kind of the time ran out, because people at some point were not able to get V4 addresses anymore, and V4 addresses ran out. So so this is just talking about the deployment incentives, right? So I call it the vicious circle of IPv6 deployment, right? So first of all, there's not much content on V6. So if I go back to 1999, okay, so not many people might have been looking at V6 in 1999, but if you had IPv6 in 1999, there's really only one thing you could do, okay? So that was to go to the Kame website, it's a university project which did V6. And if you go to the website on V6, you would find a dancing turtle. So this turtle here would be dancing if you go on V6. But if you go on V4, the turtle wouldn't dance, right? And that's pretty much what we had to do on V6. So that was kind of if you had a dancing turtle on the Kame website, you would be really happy. right? So that's really like where it stopped, okay? And then like, people said, okay, like there's nobody waiting for this. So like, why would we turn on content on v6? And Google, when they started doing the initial v6 stuff, right? Even when they had IPv6 support, they would not serve quad A records for you, right? Because they realized like if they started serving quad A records and you had broken connectivity in v6, they would lose like less than 0.5% of customers, right? So they said there's no way I can turn this on. So they had to do some kind of whitelisting process to give you quad A records. But that kind of changed over the last 20 years. So I want to like, bring up something like, so if you move to 2019, right? So what do we have on v6? So this is my hero, right? MS Dhoni, right? And like, it's kind of very important, right? Like, and the reason is like one of the if you look at one of the Ackermann reports, like for IPv6, right? They saw like a real huge peak at the 2019 World Cup semifinal, right? India versus New Zealand, that had the maximum number of like IPv6 streaming sessions at that time, right? So like, you move from something where like, only the hardcore geeks go to like look at something to something like, like a whole country can get behind. So that's really what has changed. So like, everything has now become available on v6. So like Google is on v6, Facebook is on v6, Netflix is on v6, like, Hotstar is on v6. So the idea is like, we moved from a place where IPv6 has been like more like a playground for like geeks to something that like everybody can look at and enjoy, right? So this is one side of the story. So the content became available, but there's also another side of the story I want to talk about as well. So 10 years ago, right, and India was not really a leader in v6. So it's like something I is happening in India, talking to operators there, and it's never like been something that is like high in the radar. So like, even though India got kind of a late start into the internet, like it has never had a problem with like IP addressing or so, like, a bunch of carrier grade NATs and everything, like things kind of work in some way, right? But over the past few years, like, things have changed significantly, right? So if you look at it, like, it's, so as I said before, right, it's not like somebody, like exactly like Paul said, it's somebody has to take action, okay? And in this case, so this is like from the World IPv6 launch measurements, okay? So like it talks about the network operators who contribute like most of the IPv6 traffic around the world, right? So if you look at it, there's like one here, right? That's made like a huge difference. And if you start looking at the philosophy they had, right? Like if you look at like Geo, if you start talking to the people like, Tarek and so on, right? And Ayush and like Shailene and all those guys, right? They talk about really like trying to build a network from scratch, that and they're really looking at like, how to build a network economically, how do you cut the cost, how do you keep it like easy to operate and so on. And for them, it's simple, right? So IPv6 doesn't have to be something that had to be imposed on them. IPv6 naturally made sense. So if you're building a network from scratch, you don't want to have any kind of legacy stuff in there. Like obviously you do v6, right? And then that kind of like changed the calculus like completely, right? If you look at like down here, right? Like, Comcast, it went from no IPv6 to like, something like this, right? But they had like quite a bit of legacy to move. And if you look at the mobile carriers in the US, it's mainly because 3GPP decided like, v6 will be a first-class citizen in everything we do. And IETF, we work very closely with 3GPP to make sure that like, we write up all the specs in a way that are implementable by 3GPP and make sure they work for mobiles. So if you look at it, like all these things, a lot of these things have actually been driven by mobile, right? So, and that is like what I would call the first shift, like really in the internet. We went from a fixed internet connecting a bunch of places to like a mobile internet, which connects like people. So like the numbers increased and things started making sense to do v6. And this is like a number, like again, like a Google deployment number is like 49%. Like the actual number doesn't matter because depending on how you measure it, it could be like 49% or 70%. Like, you see like a whole bunch of different numbers, right? 50 to 70% is like pretty common, right? Depending on how you do the measurement, because some people measure capabilities of like connecting. Some people actually measure what's actually like being connected. Some people measure the traffic. But the point is like India has really taken a lead in this, right? Like if you look at like a lot of the traffic coming out of India, like, v6 has become like a very, very important part of the picture. So that's kind of something I wanted to point out. So like India has gone from like, being behind to like being like really like at the forefront pretty much of the world, right? If you look at it, I would say like India is like probably like straight up there, right? Where Japan used to be like 10 years ago. Like, I was always looking to Japan and talking about what's happening in Japan, like to talk about IPv6. Now I should talk about India, like as the leader in IPv6. And if you look at it, so specifically, right, this is like, where like, IPv6 everywhere, right? Like, so obviously it's not everywhere, but like other than like, probably like, I think it's like Svalbard here, right? Like, there's like IPv6 pretty much everywhere, right? Like, so like, we're not quite close to like everywhere in the world, but like, there's very few places. I don't know if there's any people who live here, but if they do, like, we'll probably be like IPv6 everywhere, right? So there's like varying degrees of adoption, but things can just change. So, it takes like one company, one person bent on making a change to like change something from like deep red into like really bright green, right? And we've seen this before multiple times. We've seen in the US, like, Verizon turning this on, and then Apple coming up and like, turning it on in iPhones, right? So it's like a couple of people like make a difference, like, to make IPv6 deployable everywhere. And that's kind of something we've seen every time something happens, right? Like if you look at like Murai Sensei in Japan, right? And like it's always been somebody who like really pushes like things forward in a country or in like a small part of a country. Either way, there's like, if you look at like postal awards, you see that it's like real people really pushing the countries forward. So one of the things like people said is, so if you, once the transition started happening, right, like, people started looking at like, why things started working, right? And it kind of like, seemed really that IP address exhaustion, IPv4 address exhaustion was like the primary driver for V6, right? And I would say it's like mostly true, right? And because like people found some kind of economical advantages of moving to V6 because like, it didn't cost money, right? Like to get a V6 address, like, or at least as much money. So this is like a number, like, this is from the IP journal, like from September this year, right? So an IPv4 address costs like $20. So if you have like a /24 that you want to buy, it's like $5,000, which is like a lot of money for like something that probably you wouldn't need in 5 years, right? Like there's very few services that are not accessible over V6. So there's like one notable one that I'll call out, like, that's like kind of been a thorn on my side, which is GitHub, right? So GitHub is like a place that somehow doesn't work on IPv6. I have no idea why it doesn't work on V6. It should be pretty simple to make it work on V6, but it doesn't, right? So there's like very few places where you need IPv4 connectivity at this point. So like, the IPv4 address space being the killer app for IPv6 is kind of true, but not really, right? So that is kind of changing. So I would say IPv6 address space was the killer app to get like, IPv6 like past the first goalpost, right? Like where we are actually there, like we have a reasonable deployment. People still consider like, IPv6 when they want to make sure that they're able to reach the people who only have IPv6. That didn't happen like even a few years ago. So this is like something I worked on like at Ericsson. We had this initiative called the Network Society, right? And there were like, kind of 3 inflection points like in global connectivity, right? Like first of all, we had the Internet of Places, right? Like, everything was like in a physical phone. So everybody had like a small landline phone with a rotary dial and so on, right? And then we started putting like, modems and like acoustic couplers and so on to get on the internet. So there are places getting connected, like not people, right? So that's like this first like line. So like you are kind of like, peaking out at some point for the Internet of Places. And then like people started getting connected. So this is like really more like, starting off with the mobile networks and, going to GPR, like, CDPD, GPRS and so on, 3G, 4G, and so on. And the people started getting connected, right? So this is where we are. So like, we have a lot of people getting connected on the internet. Again, we're going to kind of peak out at some point, right? Like, I was thinking this is 2014, right? I was like, okay, maybe 5 billion people will have cell phones, right? And obviously I'm wrong because like there's a lot more subscribers on mobiles today. Most people have more than one subscriber, identity in a mobile network. So like probably like, let's say 10 billion, right? To be conservative. That's kind of where we're going to end up. But like the real future is in the Internet of Things, right? Like, so that's where the future of IPv6 is. So like once like everybody who needs an internet connection has IPv6, which is something, or at least like a large majority of people, I think it's going to be true in the next few years to come through. Like almost everybody is going to be capable of doing IPv6, right? So once that happens, the next part is going to be on the Internet of Things. So that's really where IPv6 is headed. And the general idea is this, right? When people say why should that get connected, right? The general idea is that anything that benefits from being connected will end up being connected. So not necessarily that you're going to start picking things to be connected, but who would have thought we would need a connected coffee maker or a connected fridge, right? Or that can order stuff you don't you run out of, right? But those kind of things are happening because there's people can always find when things get connected, people come up with newer ideas to benefit from that connection. And that's really what's going to drive the internet in general, going forward, and IPv6 very specifically. So usually when we do programming stuff, we have this meta variable called foo, right? We substitute that for everything. And IPv6 over foo is a thing. When I was AD, right, we actually talk about IPv6 over foo as a concept, right? Because we have so many of these things running around that it has really become kind of a cookie cutter model where you can put IPv6 on top of everything. So we started with the LP-WAN, right? 802.15.4 was probably one of those first constrained technologies that started getting on IPv6. And if you start looking at it, it's very, very constrained. I think Michael can tell you a lot of nice stories about it, right? In the constrained space. But in the constrained space, the MTUs are really small. And when you talk about 40 bytes header, that's pretty much very close to the link MTU in a lot of cases, right? And so people said oh, is IPv6 the right choice? But a lot of people had the foresight to do IPv6 and kind of put in additional technologies like compression, right? Stateless compression or stateful compression to make sure that IPv6 could still work and address all these nodes, and all these nodes can have connectivity to the internet. So these become first-class citizens on the internet and can do the same kind of things that any other IPv6 nodes can do. So there's a bunch of working groups which are dedicated to pretty much doing IPv6 over some kind of constrained node, right? 6LoW being the most I would say the most widespread one, and Shweta who's from my IESOC, she's one of the chairs of 6LoW. And they've done quite a bit of work. If you look at think of any technology, if you want to think about Bluetooth or Bluetooth mesh, right? Or the PLC stuff, all of them run V6 or NFC, right? All these things are capable of running IPv6 on top. So IPv6 becomes some kind of layer where all these constrained technologies with very, very different characteristics in some way. If you look at 6dish, right? 6dish is more made for deterministic networking, but all of these converge onto IPv6, and then you can build the applications on top of these without understanding really the underlying technology. So if you look at IPWave, similarly, it's for vehicles, right? Moving cars to cars or cars to infrastructure and so on. And LP-WAN is something you build a network where the devices can take a single battery and survive for 20 years, right? So they have probably bits per second of throughput and really, really small link MTUs, right? So how do we actually get IPv6 on these? So these are all the problems we worked on in the past few years. So I charted IPWave and LP-WAN, right? So it was really daunting to start off when looking at some of these technologies, but we actually have successful deployments and interoperable deployments of everything on these technologies. So there's this concept called IP as the waste of the internet, right? So if you look at how the internet started off, right? So there were different kind of networks. So if you look at today, Ethernet is pretty much I think it won right at the end. But there were a lot of networking technologies. There was token ring, and there's whole bunch of other stuff, right? There's DECnet, there's a whole bunch of other things. And then we had IP and IPX and CLNP and so on. But IP kind of really won out at the end. All these other technologies at layer 3 really didn't get through past 2000s. So IP became something that you can always depend on and start to build your applications on top. So that's kind of what led to the internet, that you could kind of separate out the networking technologies from like the applications that sat on top, and IP became the waist of the internet. And then the internet kept progressing, but things started changing a bit, right? So like now, if you look at it, it's not really IP as the waist of the internet, it's really HTTP, right? HTTP and TLS is really the waist of the internet. Like people, if you take away IP and TCP, like people wouldn't care anymore. So like, people are doing DNS on top of HTTPS, right? So HTTP has kind of become the waist of the internet for I would say the regular internet, right? But again, like this is another step, like, and things are going to change. And I do see like the IPv6 becoming the new waist of the internet with like some kind of associated protocols where, with the UDP or DTLS, depending on if you want security and CoAP, kind of fitting in the waist, right? If you look at like a lot of the newer technologies, all these things are getting compressed. So if you look at the IoT space, IPv6 is pretty much a given, like anywhere you go in the IoT space. And then again, like, CoAP is becoming like one of the bigger protocols. There's of course other ones like MQTT, which is like more started off with a proprietary thing and getting more open. But like if this can become like a proper application stack where everybody gets to connect to everybody and kind of bring back the end-to-end architecture that we had before. So just to like kind of summarize here, I have just a couple of minutes. So I see the future of IPv6 as like very, very bright, and it's like kind of like, leading a lot into the IoT and like, the constrained devices, like kind of bringing up the volumes of IPv6 going forward. So kind of that's why I said, okay, like IPv6, like everywhere and on everything. So I do see that like coming to fruition over the next couple of years. So that's pretty much all I wanted to talk about. So thank you.
Thank you, Suresh.
Yeah,
Amazing to hear from you. Any of the panelists, if you guys have any questions, feel free to unmute and ask your questions as well. I realize that panelists cannot use the Q&A, and while we wait for any questions from the audience. No questions? Come on. I think we need to sponsor people coffee at least in the morning. Send every attendee some. Suresh, one question that I would like to ask. I think that's one thing that we covered in the maybe in the panel as well. So if you want to postpone to that, that's fine. But what would be a lesson learned in standards development after this long history of IPv6 that we have gone through? And when people propose some new protocols, what is after your journey that you have been for all these years, what's your one guidance, general guidance, not just related to IPv6, but what's something one person needs to do correctly if they want to deploy a new protocol in the internet?
Okay, so like thanks, Dhruv. I think like one key thing is that like make sure that like people have incentives to deploy the protocol, right? Like you need to make sure that like the different actors in that protocol need to have an incentive to deploy the protocol. So like just like in this case, like the users, like what do they get out of IPv6? Like think of all that and make sure that those value propositions are conveyed instead of talking about technology most of the time. Because I think that's kind of what we did, like in the IETF, like when we started talking about IPv6, we were talking about, oh, it's got like, stateless address auto configuration, or like, it's got like router discovery. It can do like all these zero conf things, right? Like, we were always talking about technology, but we never talked about like, how it can change the economics of the system, right? And I know like, Fred, like, he used to do that like quite a bit with ISOC, right? When he was doing the outreach. But I think like, ISOC is kind of like, we work very closely with them. And that's a lesson we learned, right? Like we kind of work now side by side with ISOC. So now when I was AD, right, I kind of found somebody in ISOC like who would work with us to kind of put this out into the, like, I would say the market, right? Or the community where like, they try to explain things in a way that kind of more fits like what people's needs are rather than just about the technology. So it's not just technology, it's what it can do for you. Okay, so I think that's like the education part of it is something we need to do, even though we don't think of it as a responsibility. It's like for like technology folks like us, we need to make sure that people understand the value of the technologies itself.
Suresh, we have one question in the chat, which is from Michael. It seems that the geo is a unicorn. Are there some other examples of big greenfield stuff? It seems that we are having a lot of difficulties with IPv6 for things which are not capital I internet.
Yeah, so really good question, Michael, right? Like, so I think there's like not too many networks getting built from the ground up. Like another one I can think of is like Rakuten in Japan. So Rakuten is like something, again, like built from ground up. So when people build from ground up, it's easier to do, right? But there's not like, too many new networks that come up. But we've certainly like come past a point in the capital I internet, right? Like where V6 kind of is included in everything. So if you like specifically on the mobile side, right? Like, the IPv6 bearers on a 3GPP network, like get the same kind of treatment as like IPv4 bearers, even better in some cases, right? So I think like the infrastructure is there. The incentives for people to move over is going to change per country. And Michael, you're in Canada, right? Like Canada is again one of those countries which is like very IPv4 rich, right? Like, so things are going to take a bit longer. And like when I was in Canada, and I lived in Canada, right, I had to kind of call my ISP and get through to somebody who could explain. I could explain to get the thing on. It was tech savvy, if you know them, right? So the idea was like really to kind of like be activist in getting your net stuff going. But for things, like one of the kind of counter movements that I see, right, where IP is becoming irrelevant is like this kind of like bunch of proprietary networks that come up, right? That can build a whole integrated vertical stack, right? Like, stuff like Sigfox, it didn't have to do V6, right? Before they kind of came to the IETF, they were kind of going with their whole vertical stack. I think that's what we need to watch out for in the things movement where IPv6 gets left out. That is what I see as a real risk in that space where somebody could build like this huge vertical thing. I don't know, like for example, like, Amazon comes up with something, right? Like AWS, IoT, and then like a whole bunch of people move in there and they don't really care about the IPs in there. That's my biggest worry, like in that space to get left out.
Suresh, we have 1 minute and 3 questions. I will let you pick which question you want to answer. There's a question on new IP, there is a question on economics, and IPv6 on access. So feel free to answer any of them live, and you can always chat your answer later on as well.
Yeah, I'll come back to like, kind of the whatever's left over, right? I'll take the new IP one, right? Like I think I would say it's very interesting. Like, a lot of the times, like, I was like in a research group in Ericsson at some point, right? And we always think about these clean slate approaches. But one thing is like, there's like a lot of inertia that makes like clean slate approaches very difficult to do, right? And like I would say things have become a bit easier these days to try this out, but to go into production is like hugely different, right? I do P4 programming, right? Like, to do like, fast path and programming of like bare metal, right? And we can do like with stuff like P4, networks have become way more programmable for you to try things out, right? But like, how do you get this out in the open? I worked on, ICN stuff, right? Like CCN with Xerox and so on, right? Like a lot of stuff, like excellent, like technology, but how do you actually do the incremental deployment is really what we need to address. Like it took V6, which is not very different from V4, right? Like it is significantly different, but I wouldn't say it's like not like new IP or CCN, which is like totally different beast. So I would say like think about how you can incrementally make changes instead of doing a clean slate. That's my recommendation from the past experience.
Thanks, Suresh. So we'll move to the next presentation. Let me share my screen. So following, we have Mike Ackermann, who will be talking about IPv6 deployment at enterprises. Mike is from the enterprise. He is the lead network engineer of system management and monitoring at Blue Cross Blue Shield of Michigan. They are a huge insurance provider, health insurance provider, and he's responsible for planning, engineering, deployment, admin, everything related to running enterprise networks. He has been quite active in ITF as well as in INTC. It's really important for us to have the perspective of enterprises when we are doing any of our protocol stuff, as most of our protocols, though initially thought of to be run on web, but they also run on the enterprises. So it's very important to have enterprises perspective taken care of. So we are grateful to have Mike come and talk about IPv6 stuff at the enterprises. So off to you, Mike. I'll stop sharing and you can share your screen.
Thank you very much, Drew. Hopefully I am now sharing my screen. Can everybody see it?
Not yet for me.
Okay,
No, I don't see it yet.
that's not good. Let me do the share again.
Yes, it's coming in.
How about now? All right, on the second try only.
There we go. Yeah.
There we go. So thank you, Drew. Really appreciate it. And thank you so much for the great conference y'all are putting on. You're doing a wonderful job. And while I'm thanking, I'll thank Suresh for a great presentation. Really interesting stuff. Although I think you should have followed me. So I'm going to talk about the status of IPv6 at the enterprises. And so I want to thank everybody from the Zoom audience there for joining, and hopefully this is interesting. So let me get started with what all we're doing. And this is supposed to be a joke, but here's all the status of the IPv6 deployments at enterprises. It's probably not funny. Let's decide that at the end of this presentation, and it's maybe a little too close to the truth. So stay tuned and let's see. First thing I want to do is talk about what in the heck is an enterprise. And I'll do this really quick because most of you probably already know. You probably deal with one in one way or another. So we're large commercial organizations. We're very profit or revenue focused. Some examples are banking, insurance, like me, retail, manufacturing. But for the purposes of this discussion and IPv6 in general, we also want to include organizations that are in government, education, and healthcare. So sort of anyone that's big and operates their own networks and data centers. The business is usually more aligned with applications. I'm going to have to move this block here. There we go. And IPv6 is really an infrastructure issue, but just know that we're really driven by our applications and our business and the critical relationships that we have with the public and with a lot of partner organizations. We're very budget or bottom line oriented, so it's all about money, and there's a focus on budget quite a bit of the time. Sometimes you hear organizations like ours referred to as brick and mortar, and then a big thing to say is that change to us is a four-letter word where we don't deal with it well, we don't react to it quickly. And one of the things that's very relevant to IPv6 and other similar topics is that, unfortunately, from my perspective, enterprises are rarely involved in standards development. So that's just a little background. Here's what we hope to do today. I'm going to talk about what we have accomplished at my enterprise. I'm going to talk about what we haven't accomplished that I think we should. I'm going to talk about what others that I work with have accomplished at other enterprises, and then talk about, you know, why maybe we haven't made as much progress as some of us, me in particular, think that we should have, and that's because of you know, attitudes at the top, and how can we get their attention and what can we do about that? And then you'll see that we need lots of help at enterprises, and who or what can help. And then probably the most important part is any open discussion that we can have, and questions and answers, and conclusions and next steps. And a little warning is that when I create slides, I usually put what I think is important in red text. I'm usually wrong, but that's what I think. So let's get right into it. Again, I'm interruptible at any time. I really don't like hearing myself talk, so please interrupt with questions. And to the extent Drew wants, we can have people come on live and ask questions and have discourse. So what have we accomplished at my place? We've done a lot of information gathering. We've done some research and training. We've maintained contacts with partners and vendors and customers and organizations like IETF, IESOC, BAC, and INTC. BAC is an internal organization. It's a series of advisory boards that work with my companies and other companies that we do business with. And we talk about a lot about there, but very little gets done. So I'm going to say, and I'm brutally honest sometimes, so bear that in mind. That this is, what we're seeing here is mainly academic and informational. For me, I'm a hands-on guy that likes to make progress, and maybe sometimes too quickly. The fact that it's mainly academic and informational accomplishments, that makes me sad. There's my little frown. So if it's mainly academic and informational, what do we really accomplish in terms of palpable actual progress? And there are some things. We've applied for and gotten an IPv6 address, a /28 from Aaron. Woo, that was pretty good. We created what I think is a really good address plan. And by the way, I think this is something that should be done first. And it was in our case, and I do not believe we would have gotten this address from Aaron had we have not done that. For many years, we've been working towards making all devices IPv6 capable, and I think we're there. You always have some outliers, but I'd say we're 99% there, so that's going well. But we made it part of what we call the life cycle progress or process. And so it just happens by natural course of action, and when devices come up for budget review. So that's good though. And we've early on we identified a lot of use cases and priorities and chronologies and the order of which we would want to address things. Built that into a draft migration plan, which included transition technologies. And we also built an IPv6 lab. So those are all pretty good accomplishments. I still don't sound happy though, do I? So that's a good base start. Then what? All the accomplishments I listed were early on in our IPv6 journey. And so that was probably at least 5 years ago. At that time, management concluded that there was really no business need for IPv6, pulled it off of the budget, took it out of any project plans. Project teams then got disbanded. And so for the last way too many years, very little recent activity, visibility, or interest in IPv6. So there I am again, only this time I'm doubly sad. I'm going to talk about now what we have not accomplished, at least in my opinion, and the biggest issue there is we haven't really turned on IPv6. What does that mean, at least to me? That means that IPv6 is not being forwarded by layer 3 devices. That means it's not going anywhere, and so it's limited to subnet traffic and lab traffic, which really means basically nothing. We have not done training for technical staff, which is a barrier to getting things turned on and making progress. And as far as testing, very little, and our lab is dormant. And so the result of all that is that the prevailing opinion is that IPv6 is not considered a need for the foreseeable future. And now I am triply sad. So let's turn our attention away from me and my organization. What have others done? And these are people that and organizations, other companies, business partners that I work with. And we talk about this, and we don't talk about it as much as we did a few years ago, but here's what I'm seeing over there. And these are the same categories that I just judged my own organization in. And so in information gathering, there's some. Research and training, a little. Maintaining contacts, it varies, but not too much of that. Applying for an IPv6 address, very few that I'm aware of. Creating an address plan, I get questions about that, how to do it, but very, very few people have actually done it at all. Identifying use cases and priorities, limited there as well. Draft migration plans, virtually none. And building an IPv6 lab is extremely rare. So the bottom line there, unfortunately, is that as bad as I think we are, most enterprises are in worse shape when it comes to any kind of IPv6 progress or deployment. So let's look at why such limited progress. And here are the reasons from my perspective and from what I've heard from others. There's no perceived need for IPv6. Everybody says they think they can use IPv4 for the foreseeable future, and many times you hear forever. Another reason is that, you know, the enterprises are focused on whatever the hot issue of the day is. There's always some problem or some hot project, and that if they'll even talk about IPv6 at all, it'll be seen as a future need, and then they'll usually say maybe, and then if you get really specific, they can say things like, oh, maybe 2, 3, 4 years. The trap there that everybody seems to ignore is that if it's really 3 years out and it's going to take 1 to 3 years to get there, shouldn't we be starting now? And everybody will shake their head and say, yeah, probably, but how about next year? And I've been hearing that for several years. Some of the reasons that people like to postpone IPv6 include cost. It just is going to cost us too much. We don't have the time. It's too complex. It'll disrupt production. Now that's a big one, and that is important, but we use that as an excuse to not try anything new. We're overly concerned there, in my opinion. And then a big one is, and I think I've already mentioned this, the lack of understanding of IPv6. We need training there, and we're not getting it, and it's not in the budget. And a big thing is we just have other priorities. We have other hot things going on. So the bottom line there is the people that need to care are the CIOs or the decision makers at IT organizations, at enterprises. And that's just not on their radar. They're just not thinking about it. So that's the red bullet at the bottom here. So the question becomes, what can get their attention? And I have a whole bunch of ideas here, and I'll warn you in advance that few of them have worked, some of them haven't worked at all, and I keep trying. I still think these are valid, but I'm going to run through them. Sit back and relax. I have 3 pages of them, and I hope I'll get more from you, or maybe better ways to present them. But here they are, and I'll go through them relatively quickly. IPv6 only network sites or applications or devices. That should be a fear factor for us, because that could mean that we can't connect to customers or business partners, or they can't connect to us. So that gets a little bit of concern generated sometimes. How about new customers, partners, mergers, and especially those types of things outside of the US? True, but that doesn't seem to be a big issue for us, and we seem to be able to nat our way around that when it does happen. Here we got something in red, though, and that's the recent US government mandate to use IPv6. And most of us enterprises have some form of a business relationship with the government, and so that's going to start to get attention. That's fairly recent, and it's one of the few things that most of the people that I talk to at other enterprises can't ignore. Almost every other issue that you'll see that I bring up here, they'll have a reason that they can ignore it or put it off for a couple of years. This one's a little tougher, so hopefully this can catch people's attention and hold it for a while. Suresh talked about mobile. Thanks again for that. It's the mobile carriers are deep into V6. It's more of a seamless interface, and I think there's better support just in the protocol. So that gets attention sometimes, because I think everybody knows that mobile is big for our future for everyone. A frustrating category for me is that, you know, you hear about a lot of products, networks, and platforms that prefer or run better with IPv6. And I've been trying to leverage that one for quite a few years. However, most of the time when I collect related metrics, you know, in the faster path or shorter hops or better availability than IPv4, I don't see it. I want to see it. I want to see that really bad, but I'm not. I'm seeing them equal, and frequently IPv4 outperforms them. So I hope that changes. I will say it has changed. Many years ago, V6 used to be very poor in all these categories, and I'd say it's approaching even now, but I think to get enterprise attention and it cause us to switch, it needs to be better, and I think it can be. Similar to that is dwindling support for IPv4. I keep hearing that, but I still see it out there, and I don't see the warnings from vendors, whether in the networks or in devices, oh, the V4 support is going to go away. And even then, I don't think we'll be worried until this happens. And this is what I hope happens, actually, that, you know, a network or a product vendor says, oh, you know, we can keep V4 out there for you if you want, but it's going to cost you extra. So I hope that happens someday. Another advantage that gets impressed sometimes is that IPv6 has better geolocation information, and that the marketing folks like that. This is page 2 of that, and this is the technical page. So nobody likes to talk about this, but I think most all these are very valid, and so I'm going to keep saying them. And the very, very top of that list of technical features is PDM. And I'm kidding slightly there. You can talk to Nalini about that, but I say that kiddingly because that's an RFC that she and I worked on together. But I will seriously say that when we get attention of enterprises, they're going to like what PDM provides, and I think it'll be a big selling factor. As will the rest of these. I think IPsec runs more seamlessly in V6. Anycast, the same thing. We've got segment routing and flow label and other things that are nice features that when we're finally aware of them, I think we'll like and we'll leverage. Another thing is that during a V6 deployment, you have no choice but to refresh your address plans, do things like more aggregation and more efficient routing tables, reduce your ACLs as a result of some of the previous things there. And you can come up with more meaningful addresses, better use of TCAM and ASICs chips in your infrastructure devices. So I think those are all good things, but they're not things that very many people want to talk about, but they're valid in my opinion. Another category that people talk about a fair amount is that using the extra address bits for operational benefits, things like site identification and immutable DSCP. Some have baked in name and brand recognition. I like things like diagnostic information like VLANs IDs built in there. General semantics and security zones get some press sometimes. So those are things that are niceties that sometimes get a little bit of attention. And the final page, thank you. One of the biggest things that you hear about, and Suresh addressed this too, is the running out of addresses. And you need IPv6 for that. And that was a big scare tactic a few years ago. And I think it's legit. Unfortunately, in many cases, it doesn't seem to be a big issue. Now, use us as an example. We do have a Class B that we don't use enough. And then internally, we use 1918 addresses with NAT for going outside. So we don't have an issue, and there's many that are in that same category. So that problem isn't as big as we think it could be, or some of us want it to be. The NAT elimination that comes along with IPv6 deployments, I think that's a big issue, but not everybody hates NAT as much as I do. I can't figure that one out, and some people actually think it provides benefits. I think that's crazy, but I'm still citing that as an advantage. IPv6 has easier and more intuitive subnetting. And here's a category all to itself that actually does get some attention, and I call it popular CIO buzzwords. And these are topics that when you bring up any of these areas to a CIO or anyone in IT management, they can't ignore it. These are the hot topics of the day. And every time our organization or others have deployed these, there's been addressing or other issues where IPv6 could come, and sometimes has, to the rescue. You know, for cloud, sometimes new addresses are required. Same thing with big data applications, SD-WAN and SDN deployments. Suresh already said about IoT. I think it's obvious there. Enhanced security, some people believe that and some people don't, that the larger address space is harder to hack. I think it is, so I'm throwing it in there. And then some of the newer things is is 5G and blockchain. Again, more addresses there, and I think IPv6 will be a benefit in terms of addressing those needs. So, warning again that to me, all these are valid and convincing reasons why we should be looking at and deploying IPv6, but they just haven't been convincing to date. It could be what I'm saying, the way I'm saying it. I think others have tried some of these same things. So an outstanding question there. What should we add or change about this list, or should we be presenting it in a different way? Because I think that's the answer, is getting their attention and getting reasons that they need to look at these things. So I guess what I'm saying there is I and people like me need help. And who can help us? And I think organizations like we have here today and events like Connections are wonderful in furthering that cause. And in my opinion, there's two different basic areas that we need the help. And one is, how can we tell them or show them and educate them on what they perceive as a lack of perceived business case? We need to help the CIOs understand the IPv6 business value. I still believe it's there. I've tried to articulate that on the previous pages. People aren't buying it. So I think it's legit, and I just think we need to come up collectively with a way to sell it. That will get IPv6 on their planning and budget radars. Only then at enterprises does it become real. The other general category is to educate the technical and operational personnel. That will remove the fear, uncertainty, and doubt that a lot of technicians at enterprises have about IPv6. They just don't understand it enough. And enterprises, when they don't understand something, they're reluctant to pursue it. And I think I've said this a couple times, that we do not have training budgeted, even IPv6 training budgeted, even for next year. I've been crying about this for years. Now, if you put those two bullets together, that's really dangerous, because we don't understand it and we ain't getting the training. So we could be trapped here forever. But to the rescue, some webinars by INTC and Aaron have helped a lot. I've gotten a lot of good feedback from people on those. People are starting to understand IPv6 and be less intimidated by it. So thank you for putting those on. They were really good. They were really helpful, and they were presented in a very operational way that enterprises really related to. So general category for help, more promotion and support from organizations like the ones that we have here today. And then if that works, a motivated staff can promote IPv6 from the bottom up. And if we've sold the CIOs from the top down, we'll be in Fat City. That's my dream. I'm sticking to it. I think that's pretty much it. Just wrap it up here. What did we say? If anybody's still awake, enterprises are not as engaged with IPv6 as they could and should be. And that's probably due to a lack of perceived business need and or technical understanding. We just don't know as much about IPv6 as we need to. And the related assistance and education is what we need to make progress in all those areas. So this is a huge cry for help. And I think that's it. So hopefully you have some questions. Better yet, if you have some answers. Unfortunately, there's not much going on with IPv6 at most of us enterprises. Now, as IESOC and INTC and others, do we care? And what should we do if we do care? Thanks again so much for your attention. And Dhruv, I guess I turn it back over to you.
Thanks, Mike. Mike, there was a question from Joe earlier that Suresh answered, but I would like you to answer it as well. Do you have a tech refresh rate for technology? How do you deal with procurement? Do you require IPv6? Is it an option? Do you require vendors to meet USG v6 or IPv6 ready testing?
Yes to some of that, and let's see if I remember it all. We're on basically a 3 to 5 year cycle. And when we started the IPv6 adventure, I'm going to say it was 7 or 8 years ago, and we were going great guns for a couple of years. And one of the things we did put in, and that's what I addressed on one of the earlier slides as what I called the life cycle piece of this. Whenever something new comes up, it had to support IPv6. It didn't mean we were going to use it or activate it or that it would even be defined in there, but that the platform or the vendor product had to at least say that it was capable of it. And so we've been doing that, I would say, for 7 or 8 years. And that's the thing I said, I'd say 99% we're done with that. As far as, I think you said also something about testing it. No, we just accept the vendor's word that it's in there and that it works. There's no testing to make sure that it really does work, much less how well, much less scale and work in our environment, all of which should be happening. And that's what we had intended to do in the lab, but are not doing for the last several years. And that's where I have my sad faces.
Mike, can I ask one related question? And then I'll let Joe speak. The related question was, there was this discussion recently. Joe, just wait a second. Let me finish the question. Mike, the related question was... I lost audio. Can you hear me?
I can hear you, but I think Dhruv is still speaking.
Yeah. So, hi, Mike. Mike, my question was related to the TLS 1.0 and 1.1, that discussion that was just happening on the IETF list that people might be not aware of here. So where the discussion was related to when do we deprecate technologies that has been found to be an issue, and especially the enterprises lag behind the technology. So do you want to put your thoughts on, you have been thinking about it for a while, so related to that as well, do you have any thoughts that you would like to share? Which comes from the tech refresh rate question from Joe earlier. Go ahead, Mike.
Now, I will say that this is a separate topic and a completely separate answer. This is not IPv6 related at all, right? Right, Drew?
Yes.
Okay, and that particular item had to do with TLS versions, and the way we would approach that is different than we did for IPv6. It may change to become something like it, but right now, if all TLS versions prior to 1.2 are deprecated, and we have products that are using those, which we definitely do, and probably more than I even want to talk about, that would be identified as a security vulnerability, and we would have incidents opened against that, and we would work to address that. What frequently will happen with something of that scope is that you'll find many platforms, maybe of the same application or type, like a database or whatever, that will have that vulnerability, and it will spawn a big project that will cause us to maybe go to a new version of that product or even a different platform, or in some way address that issue. And what I was trying to communicate to the folks on the TLS working group was that those steps and those processes take time at big organizations like ours, and we can't just turn that around in a couple of months. Now, I also defended them a little bit by saying, part of this is our own problem because we don't participate in standards. We don't shape them to meet our needs and our requirements and our situations. And we're not aware of them until the 11th hour because we just have our heads in the sand. So that's, I think, what I was trying to, all the above is what I was trying to communicate on that list interchange last week, which got quite interesting for a while. And I hope in saying what I just said, did I hit on what you were asking in your question?
Yeah, Mike, great. Thanks.
Thank you.
Joe, are you still there? I don't see you in the list. No. Okay, so let's move on to the panel. And Joe, you can ask your question maybe during the panel time if you're back by then.
Okay, Drew, I'm going to stop sharing, right?
Yes.
Okay.
Okay, so let me share. Okay, so the final, we have a panel discussion. This panel will focus on lots of topics that we were just discussing related to IPv6 deployment. We will talk about deployment at the operators, at enterprises, things about IPv6 only network, transition technologies, all that. So really looking forward to a great set of discussion. And Nalini will be moderating this session. Thanks, Nalini. From those of you who were there yesterday, you know Nalini quite well. She's the president of INTC. She's the CEO and founder of Insight Products. She does a lot of performance measurement, troubleshooting, IPv6 migration, all that stuff. So she has been on the advisory board for IISOC as well. So she has been helping us in India to do this. So we are really grateful for her to be involved in this. We already know Suresh and Mike. So I will let Nalini go ahead and introduce Jen and Fred. Off to you, Nalini.
Thanks. Yeah, thanks so much, Drew. Can you hear me okay?
Yes.
Okay, great. Thanks. Yeah, so thank you everybody for participating in the panel. So we've got some new folks here now, new to Connections, and so I'm really glad to have Jen with us. She has been with IPv6 for quite a long time, though. We've seen her at the IETF for many years. She is with Google Australia, and she's worked on various parts of the Google network. And before that, she was in Cisco Russia. And she's very much an IPv6 proponent. And so it'll be great to hear from her. Yeah, next slide. And then we have, of course, Fred Baker. A great honor to have Fred with us. He's a former IETF chair, and he's the current co-chair of the we call it the V6 Ops. It's the IPv6 Operations Working Group at the IETF. And he has done so many things, it's hard to even know where to begin. You know, the last but not least is that he's written over 61 RFCs. He also does a lot of stuff with quantum over at the ITU, and I would really like to hear him talk about some of that work coming up. He also does a lot with DNS and root services, so it'll be great to hear him. And he's actually going to give us a little bit of a kick start to this panel. So next file. Okay, so Fred, over to you. Yes, Fred's going to give a little deployment check, and then we'll head into the panel.
Okay, yeah, I put this together, to be really honest, the reason I put these slides together was to remind myself of reality and to get the latest numbers. But as long as they're together, I'll share them with you. At least as of last Friday, I was looking at how much traffic there is in the world using IPv6, which to me is the real measure of how much deployment there is. You can have a lot of equipment out there that's sitting on a shelf and doing nothing. But if it's communicating, then it's doing something. So what I found on Friday was that there were 79 countries that were using IPv6 for at least 5% of their traffic. And why did I pick 5%? Well, when I go below that, things get kind of dodgy and dicey. But as you go above 5%, then you start to get stable results. So if you look at the top of the graph, that top line is actually Belgium. There are some countries up there that are generating a whole lot of traffic. Down at the bottom of the graph, you've got some countries that are just really getting their feet wet. So 79 countries that are using IPv6 in an important way. Next slide, please. Now, taking just the top slice of that graph, next question is how many countries are using it in a way that would challenge IPv4? And from my perspective, that would be probably about half of a system that's using them should generate about half of the traffic using either one for it to challenge IPv4. And I found 13 countries that were in that case. And they're all over the world. They're Belgium and Germany and Malaysia, and India, Greece, all over. So next slide. Now, much of my audience being in Asia, I thought it might be interesting to you to know where Asia stands worldwide and where India stands in Asia. Clearly, there are some countries in Asia that started a long time ago, but what's happened fairly recently is that a number of countries, 21 countries, are now generating a whole lot of IPv6 traffic. And Malaysia is one of those ones, and Malaysia and India are among those that are on the half and half level. Next slide. Now, we get numbers from all sorts of places. Google is very public with their numbers. APNIC is as well. And APNIC has the interesting characteristic in the way they put in their numbers that they use Google Ads, and a Google ad will have 3 names in it. One of the names will have only a quad A, which is to say an IPv4 record. One of the names will have only I'm sorry, did I say quad? An A, which is to say IPv4. The second set would have quad A records and therefore IPv6 addresses. And the third one has both. So we can tell whether somebody's capable of using IPv4 or IPv6 by whether they will respond to either of the first 2 names. With the third one, where they actually have both types of records in the same thing that you look up, then the system actually has a choice. And the one that it chose, it presumably chose for a reason. So APNIC argues that the first few are IPv6 capable, and then when it has to make a choice, it tells you whether it prefers IPv6. And in India, what we see right now is that those that use IPv6 typically do so because they prefer it. Next slide. So now, if I were to look at the same page and look a little further down the page, it breaks all the traffic out by autonomous system number. And so I said, fine, I selected the second from the top one, which is Reliance Geo. And so the red and the blue line across the top tell you about Reliance. And then the green and the yellow lines tell you basically about everybody else, which turns out to be, there's a number of companies, but the traffic sources primarily are in 4 companies that are, or 3 companies that are telephone carriers. So next slide. And this tells you who those companies might be. I said that Reliance was the second from the top of the list. Actually, the top from the list is Robert Bosch Engineering, which is an enterprise. It's not a service provider. Everybody there seems to be IPv6 capable, but nobody wants to use it. So whatever that means. There are some enterprises here, Cisco's in the list and so on. But most of these are service providers. So that's really a bit of color, another way to look at some of the stuff that Suresh talked about. I find the numbers and the charts useful and interesting. So back to you, Nalini.
Thanks so much, Fred. Yeah, no, this whole measurement of what the heck is going on, especially inside enterprises, it's a real challenge. But let's go ahead and start with some questions. So there's been a bunch of conversations about IPv6 only networks. And don't get me wrong, I'm not saying, I think it's probably a really smart way to go. Having said that, given what Michael said, and according to a lot of measurements that people have taken, for example, NIST, about something like 90% of the brick and mortars in the United States have not deployed IPv6 on their internal networks. What do we think about IPv6 only? Is this at all realistic? Jen, I'm going to start with you.
Hi, can you hear me okay?
Yes, we
can you hear me? Okay, good. So, well, I'm not just talking about IPv6 only, I'm deploying it. I presented it on the last previous V6 ops session at IETF and at RIPE and NANOG. We're actually migrating part of our enterprise network to V6 only. So I can tell you it's real. I understand that some companies might not have solid business case yet, so they might not be deploying IPv6 yet. But yes, some companies actually turning off IPv4 already. So it's just two different areas, two different use cases, and yeah, so I can definitely confirm that it's very realistic, it's very real. You can do IPv6 only. Maybe not everywhere, maybe not 100%, but it's definitely real to move some of the devices to V6 only mode in enterprise network.
Great, thank you so much. Now, Mike, how about you? What are your thoughts?
Well, first, I'd like to say I'm sad that I'm on a panel without Michael Richardson. So, but I'll quote him and what he put in the chat, that IPv6 is for cats. You cracked me up. Anyway, back to the question. Sorry about that. I read this question to be, should we be going in the direction of an IPv6 only network? And I could say that that's probably a worthy end goal, but I don't see any way that would be one of our first few steps. I just want to get some into our network someplace and then maybe migrate in that direction. But I see us being dual stack and other transition technologies with V4 still in our network for a long time, even when we do finally get started with an IPv6 deployment. And did I interpret that question right first?
Oh yeah, no, definitely. In fact, I'm just going to say I'm going to try and keep out of the discussion as much as I can. But I'm telling you, I know enterprises who block IPv6 on their internal networks completely. It's just yeah. Anyway, so Fred, what about?
We're not forwarding it, so that's effectively blocking it. It's not like we have it in firewalls, but it's just not flowing across any layer 3 device, and that's unfortunate. Yeah, I'd love to be able to say
from a security perspective, I would dispute that. It may not be crossing a router, but it's probably crossing an Ethernet, and that can be a security issue.
Well, it's definitely on Ethernet, and it's definitely traversing subnets, but that's it in our situation, and that makes the traffic that's being transported via IPv6 relatively meaningless, unfortunately, and small in terms of numbers. I was going to say, I would love to be able to wave my magic wand and get right to IPv6 only, but I just don't think we would be capable of that.
So what about you, Fred? What are your thoughts on V6 only?
Well, discussion of V6 only within V6 Ops started out as a discussion between the chairs, which is to say Ron Bonica and myself. We figured that the whole point of a transition is to transit. If you want to walk across a bridge, the objective is to get to the other side. And we figured that wasn't actually going to happen unless somebody started talking about it and talking about their experience in doing so. So in the IETF, Ron Bonica and I in V6 Ops have been inviting speakers for what, 4 years? Jen, is it 4 years? A while. To tell us about their networks and to tell us about the transitions that they're trying to make. We had a gentleman from Microsoft come and talk about an effort that had going on at least at the time, to turn the company into an IPv6 only company. We had a Cisco employee come in and talk about deployment in building 26, where they turned off IPv4 within the building. We've had a number of others. Most recently, we had Reliance Jail. And Ramesh, the gentleman from Reliance, said that they have a number of different services within Reliance. And of those, one of them is 90% V6 only, and the 4 of the others are V6 only. They don't have any IPv4 in them. The only place where they turn on IPv4 at all is when they're talking to an enterprise. And they do that because the enterprises force them to. So that was really our motivation, was, you know, whether it takes a minute or a year or a decade, you're not going to get it to happen unless people that can that are actually working on it can get the opportunity to talk about it. And we had and Jen, you gave a great talk about your exercise at Google. I very much appreciated that. Now, is it realistic to happen instantly? No, it's not. But I think it will happen eventually, if nothing else, because people will be concerned, CIOs, senior engineers will be concerned about the cost and complexity of running a dual stack network. And if they have the opportunity to turn one of them off, I should think that they eventually will. And the one that they'll turn off is IPv4, because that's the one that gives them all the problems. So, my opinion, you asked.
No, I couldn't agree with you more about the additional complexity. Thank you so much. Okay, next question. Okay, so Jen, back to you. Do you think the lack of participation by brick and mortar industry in standards organizations like ICANN and IETF and so on, do you think that's led to hindering the adoption of IPv6?
I actually believe it might be another way around, because I would be very surprised if many people deploy particular technology because they came to IETF meeting, heard about that, and decided, oh, okay, let's play with it in my network, right? I think normally it happens the other way around. You start deploying a technology, you find some issues, or you want to share an experience, and you go to IETF and talk about that. So I think maybe we are not seeing a lot of participation from enterprises as IETF and other organizations, exactly because they are not adopting it, right? So, and now I believe it's the right time for them to start participate, because now with everything going virtual, it's actually much easier than before, because you don't need to fly anywhere. It's much cheaper. So I think people who want to participate, they should do that because the barrier is lower, but I'm not sure that it would immediately lead to the better adoption. I think people should start adopting and then come and tell their stories and their problems and give some feedback to IETF.
Great, thank you.
And I'll agree with Jen, at least up to a point. That said, and here I'm kind of giving a fractured quote to Mike, when it comes to changing their networks in any way, talking with an enterprise network manager about any change, IPv6 being just one, the answer is no, and then the next comment is, what was the question? It is just not something that's on their radar. So I think their lack of participation in IETF has hurt the IETF in that we have developed some standards that are not necessarily useful to enterprise and hurtful to enterprise because we don't know what they think.
Great, thank you so much. Next question. Okay, so Mike, I'm going to start with you. So what do you think the business reasons are for an enterprise to adopt IPv6? And
Well,
you can.
I hope Jen has some good answers, because my presentation really contained all of mine, and right now none of them are convincing. I'd say, and I'm not going to repeat my whole presentation, but the biggest, most compelling reason is if you have a business partner that is mandating it, and the best example there for me is the U.S. government. So I hope that gets some play. Beyond that, those are my 3 pages that I bored everybody with, of reasons that I think we should adopt it. But again, none of them appear to be effective right now. So we'll keep trying. And I hope that maybe someone from the audience can add to whatever Jen is going to say too, because I'm all ears for hearing reasons that we should adopt it. And that's it for me.
Yeah, let me. Yeah, actually, I'm going to listen to Jen, and then I have one. I'm just kind of poke at you a little bit. But Jen, let's hear what you've got to say.
So, well, we did have a very good reason because we ran out of private address space, but I guess it might be a case for like bigger enterprise, but not smaller one. However, let me tell you a story. It was like 12 or 15 years ago. I worked for Cisco. We came to a customer telling them about shiny wireless solution. Look how great would it be to have a Wi-Fi, so you don't need to plug your laptops to wireless network anymore all the time. And the engineers were, oh my God, no, we don't want this. We don't want this. It's too scary. We are perfectly happy with wired Ethernet. And it's probably insecure, as they told us. What we discovered, and they did have Wi-Fi network already, because people were bringing access points, plugging them into their network in their laptops, and basically rolling out uncontrolled, insecure wireless infrastructure. Actually, that's what's happening with V6. We just discussed this, right? You are not routing your IPv6 packets, but you allow peer-to-peer communication on the particular network segment over V6 because you do not deploy it, so you do not carry it, not control it, right? So it's one of the reasons to do that. And also, listen, there are more and more, not so many, but numbers are increasing, of IPv6 only networks out there. So what if you connect to that network, for example, by visiting Google Office? Our guest network is V6 only, and you need to connect to your VPN corporate infrastructure, and you cannot because it doesn't support V6, right? And the last reason I would mention, actually, and I know about at least one use case, when people deployed V6 only, partially migrated their network to V6 only, freed up some address space, and were able to rent it out, getting some money back on IPv4 market. So, yeah, I agree, enterprises might not have many reasons now, but it's a matter of future and how urgent your deployment is going to be in 5 or 10 years' time.
Yes, I tell you, Jen, I think enterprises could do worse than look at what Google is doing. I'm telling you, I'm so glad you're on the panel. But Mike, I'm just going to poke at you just a second. Mike is one of my dearest friends, so I think he'll forgive me. So what if I know there's some health insurance companies. In fact, I don't want to name them by name, but they're your competition. And so if there was somebody who was your competition and they adopted it, would that make you guys move? I'm not saying they are. I'm just saying if they did.
It would. I don't think that's a strong reason, but it's a reason. And you never know how C-level people are going to react to something like that. So I'd say it's worth a try. I've heard the same thing from the banking industry, that if this other bank did it, then they might have to, just to keep up with the Joneses. So I think it's a good idea. I think I'll add it to my list along with a couple of the other things that Jen said. I don't have the killer idea yet, but I think I'm hopeful that a combination of all these ideas eventually win people over that are making these decisions.
Sure. Okay, next question. Okay. Suresh, what should an enterprise do? We'll start with you. What should we do if say you want to go, but your ISP doesn't support IPv6? I know we were in that position at one point. So what should we? I mean, what should people do? And how prevalent do you think this is?
I think it's like changing quite a bit, Nalini, to be frank, right? And now I'm on the other side. I'm a network equipment vendor, but I'm also an enterprise, like trying to get connectivity. And this is like something like I say, hey, if you don't have IPv6, you're out. So like we are looking and positively supporting the ISPs that offer IPv6, right? And there's like quite a few of them. So I think of it as like something to positively incentivize. Like if somebody offers IPv6 connectivity, and like, you know, go for them, right? Even though other things, they might have like lower like throughputs, right? Like in the bandwidth side, or like, you know, they might be a little bit more expensive. But really the idea is to make sure that we kind of put it forward that, like, you know, having IPv6 is a differentiator. So we do have our own PI space at our company. I kind of worked with that to get like the address space. And I said, okay, like, you know, I'm going to peer with you. I'm going to do this over V6. So it's like there's business in it for you, right? I think that's like one way to look at it, right? But if you have like very, very tight timelines, right? Like, you know, things might get a bit iffy, and especially if there's no competition. So this is like really in Canada, like, you know, where there's like a bit more competition than in the, like, you know, let's say in the rural US, right? So if you're in a city, we are kind of okay, more than 2 ISPs. But if you like, you know, if you're in like somewhere in rural US, it becomes like very, very difficult because you probably have like best case 2 ISPs who don't want to compete. So I think like one of the things I kind of realized, like, and I've changed over like last 20 years, right? So IPv6 is not a religion. Like, you know, when like for me, it was like a religion, like, you know, to be done at like all costs, right? And at some point now, you still have to evaluate, try to be like, do things that are IPv6 positive in a way. But at some point, like the enterprise needs to do its thing. So if it's like medical insurance, that's like the primary goal, right? And then like IPv6 is something that's going to, like, you know, keep your business continuity into the future and so on, right? So think of it that way, and incentivize like people who do positive things for V6. That's kind of my recommendation.
Thanks, Suresh. Fred, what is your opinion?
Well, so I was working with a company, a small company, that had an IPv4 network that was located in, I think, 5 major places, and wanted to add IPv6 to it. And the way we got it to happen, we were actually fixing another problem, which I think this is often the case with enterprise. But we had a problem with at least one of the ISPs. There were 2 ISPs involved, and the company switched to different ISPs, and those ISPs happen to support IPv6. So that thumb on the scale enabled them to move. I think quite often you're looking at something like that. You're solving more than one problem, but you solve it in a way that enables you to deploy IPv6.
Jen, what is your thought?
Well, I think first of all, if your ISP doesn't support IPv6, the first thing you need to go and ask them to enable it for you, because quite possible nobody has asked them before. And it means that you probably need to add IPv6 support to your requirements you provide to an ISP or your selection criteria for an ISP. But honestly, I believe for an average enterprise, ISP support, IPv6 support on ISP uplinks is the least of the problem. If you want to deploy IPv6, getting IPv6 support from ISP would be the easiest. You need to do a lot of other things, and you can do them while you're waiting for your ISP to get IPv6 connectivity. Safety and address planning, enable it on your internal systems, and so on. That will take much more time and effort than just talking to an ISP. So yeah, don't worry about ISP too much, but definitely talk to them.
Sure, thank you. Next question. There's an IPv6 expert who claims that because a lot of people have IPv6 at home, and everybody's working from home, that they now, enterprises are now realizing that they need to get IPv6 adopted. The reason we were asking this is that, frankly, I've never heard of this. And so I was curious if you had heard of it and what your opinion was. So Suresh, let me turn to you first. I mean, I may just have not heard of it. So it could be totally the case.
Yeah, it's not that common, Nalini, right? But it does happen. Like similarly to how people didn't realize. I think it was Michael who talked about it, right? People don't realize that bring your own device was a thing, right? And people realize, hey, there's this new device is getting connected. How do we deal with it, right? And I think similarly, right? We had similar stuff when people are connecting into our VPN using IPv6, right? So we didn't have the right set of rules to get in, even though we are fully V6 enabled. So I think yes, this is true, and that's mainly because a lot of the ISPs have begun turning on IPv6, pretty much without asking, because previously you needed to be on Comcast and no Brzezinski to get your IPv6 at home, right? And now at AT&T, it just works. I have gigapower and it just turns on V6. So a lot of people use V6 and probably because of happy eyeballs or something like that, the V6 connection gets prioritized and people don't know what to do, right? And I think I haven't seen much of it, but it's certainly something I've seen for sure. And it's something enterprises need to deal with, right? Because it's similar to what you don't know may hurt you, specifically on the security side. I think Jen was talking about it too, and Fred was talking about it too, right? If you don't deal with it, it's going to be very difficult.
Sure.
And Joe, you need to move to an ISP. Joe typed on the chat the Verizon FiOS or FiOS, however you want to call it, doesn't do it. So sorry about that. Either you need to move or physically or to move to a new ISP.
So Fred, what do you think about this whole people are moving to IPv6 because of folks at home?
Well, I'm the one that found that link and sent it to you. And my sense is that might be happening to some degree, but it's not something I've run across. And so I've actually been chasing down the guy that made the comment, and I'd like to see his data.
Hey, Nalini, would you mind?
I know. That's what I'm asking, Fred, because I know you sent that, and I was like, I've never heard that hit it either. I mean, it could be totally true. It could be totally true, and I'd like to see the data too. So yeah. Next question.
Well, now taking a look at the Q&A. Marie Brierly, Marie, is asking a similar question. She keeps hearing, she says, that ISPs might turn off IPv4 in the 45th century. And she wants to know whether there's any validity to the rumor. And well, in the 45th century, there might be, I don't know. But I'm certainly not hearing that in great degree from current ISPs. That is happening with Reliance Geo. They have, as I said earlier, they have a number of services that are in fact IPv6 only. But as a general blanket case, no, I wouldn't make that statement.
Hey, Nalini, can I comment on that?
Sure, go ahead. And then Mike, why don't you go ahead and then
go ahead, and I'll go after. Yeah.
My name's not on this one, but this is something that has affected us for the last 8 to 10 months greatly. And we are not experiencing that particular problem because most of us VPN it right back to the corporate network. And so that doesn't affect you. However, with the increased amount of traffic due to the pandemic, most of us are now considering a split horizon deployment where we will have to deal with that. But I don't think any of us are having an issue with it yet. It's something we're thinking about. So if that forces us to start looking at IPv6 and treating it more seriously, I think that's great. And I also want to respond to Marie's comment. I hope that happens in the next couple of years, and not necessarily that they just abolish it, but like I said in a couple of my bullets, I hope they sort of the support for it dwindles or the cost goes up, or that just in general IPv6 looks better across the networks than v4 does, which is what I've been hoping for years, but I'm still not seeing it consistently yet.
Yeah. And just to add something on top of it, right? Like I think like Joe kind of like, alluded to it on the chat as well, right? So Marie, like just turning off v4, probably cold turkey is not like happening much, right? Other than like, what Fred said, like probably like a few companies here and there. But there's a lot of people looking at providing IPv4 as a service, like build out a v6 only network and put like v4 on top, right? So I was chairing the software working group, and there's like a whole bunch of like technologies that allow you to do it, right? They don't have that much adoption. Like I would say millions of users at this point, right? Like not tens of millions. Like I would say like, Free, for example, in France is like one. So like there's like a few people who are doing v4 as a service on top. So it's like a v6 network, but like, if somebody wants v4, they would get it as a service on top for an additional price. Like just like you would pay for an IPv4 address today, like a static address, you would get like IPv4 as a service. So that kind of thing is probably like more likely to happen before like v4 is totally turned off, because as I said before, there's like still sites that are v4 only, unfortunately, right? Like, GitHub, for example, is like something that like, a lot of us use, and it doesn't do v6. So I think like for the foreseeable future, it's probably not going to go away, IPv4, but like at some point, like there's like a point in time when the traffic is going to be small enough to cut off.
All righty. Next question. So Suresh, you're up again. So can you speak to the current protocol controversies? What's going on, and what is each side arguing?
How did I get stuck with like being the only person to answer this? Anyway, so so like I'm going to be like very politically correct on this one. Okay, like I was the AD during a lot of these things, so I just don't want to take like a very strong position. But I can summarize this like in a very, very simple way, right? So there's like, if you look, there's like a Dave Clark paper called like Tussle in Cyberspace. So there's like like the intelligence should be at the end or in the network. That's like one kind of thing, and how a protocol grows or doesn't grow. So I think that's kind of leading to like kind of conflicts everywhere in the internet, and IPv6 is one of them. So the question is, how stable should IPv6 be? So we like, I was like trying to push like IPv6 into full standard, right? Because we thought we got like the stability like of the specs and so on. So we moved this to standard to show that IPv6 is stable enough for everybody to use and deploy. But on the other side, there's like, a lot of disruptive changes coming to IPv6 as well. And I mean disruptive in a positive manner, right? Like that could change like the future of IPv6, where it goes. So there's like always this tension between like, how we keep the things we consider sacred, which is like, being like end to end, and like, making sure that the network doesn't mess too much with your packets that are going end to end. It's like one side of the story. And the other side is like, hey, the network wants to do like a lot of cool things with the packet to help the packet get somewhere. It's like another side of the story, right? And I think this is what is really causing the controversies today, right? Because like Jen is like involved in like, one of these proposals, for example, right? Like where there's like stuff changing like in the network, or like, you're trying to route not based on like, what you would route otherwise, but kind of going back to source routing kind of things. So it's controversy because there's like people who have well-founded arguments on both sides, but I think it's like a healthy thing for us to have these discussions, right? Like where we look about like, where we came from and how do we keep the things that matter to us while also making some kind of future progress on things. I don't know if that answers the question, but without like, going into specifics, but if you want to talk to me in private, I can tell you a lot more.
No, I have some idea of what you're talking about. But I was just saying for the general audience, basically it's a question of, do we stay with the founding, the Constitution? Basically, it's the argument of the constitutionalists, all right? The Supreme Court. Do the originalists versus like, do we adapt to changing circumstances? That kind of thing. Yeah,
Mhm.
yeah. No, it's
So
yeah. That's
right, like so,
mhm.
I think like to really summarize, right? Like what part of the packet is is the network allowed to change, right? Like that's really the biggest controversy. Like like can I go and change something in the HTTP like payload? The answer is obviously no, right? Can I change the hop limit? Like of course, yes, right? So I think somewhere in between, right? If you look at like a routing header, like can I put in a routing header like in the path when
Correct.
the packet didn't have it? Can I increase the MTU of the packet, right? Like by inserting this, like is that allowed, right?
Yeah,
Or can I remove a
yeah,
header? So those are the kind of things that we kind of never codified because we never thought somebody would do it, right? Like to be frank, right? Like because like it was kind of self-evident to like to somebody who was like looking at it 20 years ago that like this nobody would even think of doing something else, right? But I think that's kind of like our specs are like probably like leave a little bit of room for interpretation, and that's kind of people read them differently. And I think that's really the like we are trying to be like stricter and stricter in specs. So when a spec has been around for 20 years and we try to stricten something, it makes that something that's compliant today or like it was compliant 10 years ago non-compliant to the new spec, right? And that's when people kind of start to push back.
yeah. No, it's very tricky. I don't want to dwell on this because we probably talked for quite a while. Let's go to the next question. Yeah, I have to tell you, this is where I miss live IETF, so we can sit around and with adult beverages and talk. This is back to enterprises again. So Mike, enterprises appear reluctant to pursue V6 deployment. You talked about this a little bit, but one question I'm going to throw in here about because you talked about people who could help and what ISOC and INTC are doing too. But one question that I've kind of heard people say is that if you don't pay for it, you don't value it. And I'm not so sure that's 100% true, because I certainly see people coming to our classes and so forth. And they seem to value it. I don't know, but just let me stop talking and get your opinion on all this.
Yeah. So and there's two areas. First off, yes, we need help. We need lots of help, and we need help at the upper levels with business cases and selling the decision makers on that these should be projects and there should be budget. But I think you're mainly talking about education and information to the technical staffs, and that's something that I more directly relate to. We need that badly. And as I said in the presentation with IESOC and INTC and some of the webinars that occurred in the past year, that's been of immense help, and it's really hit the mark. I mean, it wasn't just good intention. It was exactly what enterprises needed to hear. And I would absolutely say, if it's possible, to do more of that. And in regards to what you said about do you need to charge or people don't take it seriously, I think years ago that would have been more true than it is today. Right now, we are so cheap and our training budgets are so low that was greatly appreciated, not only by the technicians who got to get that wonderful information, but for the managers who didn't have to pay for it. So I don't think that's a negative, that they're free. I mean, I understand that's human nature and all that stuff. But I think what you all did last year was just fantastic. And if there's any way we can do more of that, I think it would be great.
Yeah, no, thanks, Mike. Yeah, I just wanted to.
I would say I'll just expand. I'll expand one more step on that. That it was very technical, but still relatively high level. And if we could progress to the point where you drag somebody like Jen in, who really gets into the bits and bytes and operational details, then we'll know we've made some serious progress.
Well, I'm she's on my list to call for 2021 for doing a webinar for us. I heard V6 only at Google webinar. I've heard a lot of great things about it.
Yeah, I've
So
seen a lot of
Fred,
good stuff that's done, and since she's not a panelist, she can't say no, right? She's not on the list of people that get to respond here, so she can't say no to that. No, I'm just kidding.
No, I can't say no.
so Fred, what else do you think that we can do, or what should we be doing to help? Can we do something to help enterprises?
Well, I think there is. The first comment that I'll make is that I've talked with more than one company about address plans and this kind of thing. And the first suggestion, the first recommendation that I make to them is that they assume that whatever they did the first time is going to be wrong. And they're going to learn some lessons and they're going to need to redo it. So they should leave a bit, at least a bit, that they can use as a number to go from one address plan to the next and be able to change their address plan. And one way that they can save themselves some of that pain is getting experienced help. So I think there's a big argument for help. So I think at INTC and IEEE or IESOC, we certainly have some people that can help, and I would appreciate, or I would recommend that people use it.
Yeah, I'll just say to segue one little bit on that. One of my dreams is that as we proceed with these grants and everything, that we put together crowdsource, like a deployment team, and and people who say, yeah, I'm really into security, IPv6 security, or I know all about all the things that can go wrong at clients, stuff like that, and then we can be a free help for people, because I think it's when people start looking at those big numbers for hiring. Some people can afford to hire these big name consulting firms, but a lot of folks can't. And on the other hand, it's super good training for people to get some hands-on operational experience. So it's a two-way street, really. Anyway, let's see if something like that can work. Yeah, next question, please. We're getting a little bit short on time. So, yeah. So, so Suresh, back to you for a little bit. This is a controversial one. There's been a lot of heated discussion, and I think you have brought up 3GPP about if 3GPP, if they're using DHCP6, or if they should, or just maybe you want to go into a little bit of what that controversy is and what you think about it.
So there's really two aspects of this, right? Like one of them is in the network and another one on the device, right? And so I'll go really into the network side. I'm more intimate with that side of the things, right? So when we started doing really V6 for real on the mobile networks, every mobile got a /64, right? Delegated to it. It's not really a delegation. The whole 64 is yours, but you cannot really use it for anything other than your interface. And then we said, okay, maybe we can do a DHCP6 prefix delegation to the mobile to give it a larger prefix. So if you use it for tethering and so on. And one issue we discovered is that there's a concept called the IP CAN session in 3GPP, right? Which is associated to a mobile, IP, the content network, is defined using a prefix, and there's only one V4 prefix and one V6 prefix can be there, right? So there's no way we could add a second V6 prefix into the network, right? Saying the mobile has it. So what we did is I worked with I was at Ericsson back then, and I worked with somebody from Nokia, and Temo, what we did is we came up with what we call the donor prefix. So we had a V6 prefix, like a shorter prefix, and then we had a /64 that was given to the mobile as in the middle of the prefix. So we would advertise the whole, let's say a 56 or a 48, as the IP CAN session, and then you'll hand out one of the the 64s to the mobile, right? And then things will just work, right? And then if you ask for a PD, you would get the rest of the prefix, but with a hole that the mobile got on its own interface. So that's something we solve protocol-wise, but that doesn't solve the stuff on the device side. So for the device side, like the device OSs need to support it, right? This is like really up to Apple for iOS or like Google for Android to turn this on. And the way I understand it, right, and I think like Jen probably knows way more about this than me, right? So there is like really some issues doing this on Android, right? And I know Lorenzo kind of has like a very strong view on this, but I think the technology wise, I don't think it's like a big deal. But the question is why? Because we have come up with ways of doing address sharing in V6, and there's like a RFC. I think it's like, I don't know the number right off, it says okay, you need to give at least a 64 to a mobile. So the idea is to just stick to that limit and use the 64 the mobile gets. And even back in early 2000s, right? Margaret wrote an RFC for 3GPP. We worked on it, kind of helped it out, right? Every mobile gets a /64, things just work, right? We have enough IPv6 space to do this the right way. So the question becomes what do you use DHCP for? And I think that's more like a discussion between the customers of the device OS and the implementers of that. Jen, did you want to add something there?
Sure.
I was thinking about slightly different perspective from enterprise perspective. When we start migrating to V6 only, we actually found that we have many cases for prefix delegation, which we didn't consider before, because on V4, you basically, whatever you plug in your network, it doesn't matter if it's a host or a router. If it's a router, it will be doing some NAT and pretending it's a host. In V6, you don't want to do this. So I found that I have a lot of cases when users plug in not just laptops, they plug in routers into the network and the ones that start to work. So actually I realized that prefix delegation is becoming kind of expected standard service, which I would like network to provide, right? And I'm talking about PD. I'm not talking about this very hot and contentious topic of assigning individual addresses to devices with the DHCP. Yeah, because I don't want to have this discussion right now here, right?
Yeah.
But yeah, PD actually does have a lot of use cases, especially if you're running V6 only and not a dual stack.
Yeah.
Thanks, Jen. Fred, did you have something you wanted to add here?
Yeah, I think an important part of this question is why do they want to use DHCP v6 or whatever? I don't think that they're wrong if they make a technical choice, if they have a reason that they want to go that way. I used to work for a company that used DHCP for all address assignment, cold stop. And so when it came to deploying IPv6 within the network, they wanted to use DHCP to do the same thing. And the reason had nothing to do with the protocol. It had everything to do with their corporate policies and with the way their thinking worked, the way that they structured their network. And if that's the way your thinking works, then by all means, you should use tools that support your line of reasoning. Now, we can go on from there to discuss whether there might be a different way that you should do it, but I'll leave that to another day.
Great, thanks. Okay, all righty. Next question. So Suresh, I think this is one of the things that you were talking about is source packet routing in V6. Now, what are your thoughts? Do you think it might help with deployment, or what are your thoughts around Spring? And maybe you can explain a bit what the controversy, what for some of the folks who aren't familiar with that particular work.
Okay, so I would say kind of this has got the causality reversed, right? It's so I think it's more the other way, right? IPv6 being deployed helps with SRv6 deployment, right? Because if you look at segment routing as a concept, right? It's got multiple, I would say, instantiations. So there's two real big flavors of this, right? And if you include Gen 3, right? Like different flavors of like doing like segment routing. So like I would say the MPLS version of segment routing doesn't require v6, and we do see it like as like a vendor doing this kind of stuff, right? If somebody hasn't made up their mind to go to v6, they're probably going to go with SR-MPLS. They're not going to go and deploy IPv6 to go to SRv6. Okay, and I'm being brutally frank here, right? Like, so SRv6 is like, like a really good idea, like to put on v6 and so on, right? But like, I would say the causality is the other way. It's because people have decided they're going to go v6, they're going to put SRv6 on top. If they have an MPLS based transport network, they're going to go with like SR-MPLS. And like, there's like some people who have like different set of constraints, right? If you have let's say like, like a liquid, right? Like in Africa, right? So like in Kenya, like, Andrew's there, like, they have different set of conditions where they have paths going through like, 18 countries and stuff like that, like where they can have a different flavor of this, right? Like, which is the CRH stuff that Jen is working on. So there's like different room for different things, but I think like IPv6 deployment becomes more like a prerequisite. It's not really like SRv6 or CRH pulling the IPv6 through. It's like IPv6 already being there.
Sure. Okay. All righty. Next question, please. So, Fred, what do you think the myths are around IPv6 security and privacy, or v6 in general?
There's a few. One of them is, and I can tell you where this comes from, that IPv6 is inherently secure, and implementing v6 in your network will make it more secure. And the argument made for that is that IPv6 has a security header, which is essentially an ESP header. And I'm sorry, I really disagree with that. ESP was implemented for IPv4 before it was implemented for IPv6, so that's not an argument for v6. And it doesn't make things more secure. And by the way, it does imply a whole lot of crap. It does allow you to encrypt your traffic in flight, encrypt traffic that's going between two known points. But if you have bring your own device kind of environments, building the necessary infrastructure for that can be very difficult. So I don't know offhand that IPv6 makes things more secure. On the other hand, IPv6, we've worked pretty hard to get the security bugs out of it. And it makes for a simpler network. If you want to make something insecure, make it complex. And by making a simpler network, it's easier to secure the network. So I think IPv6 can improve security, and it can improve privacy. But to say that it automatically does, I'm sorry, no, I don't think that's the case.
Thanks, Fred. Suresh, what about you? What do you think?
A couple of things, right? Like, yeah, I think Fred is like bang on, right? Like, it's not like too many things. And there's like some stuff I did in like V6 ops, like, Fred, like a long time ago, I don't know if you remember, like 10 plus years ago, I did with Elvin Davies and Pekka. And we actually went through like a list of like myths and everything, right? With like the security issues with V6, and I can probably send you like a pointer to the RFC. But like, there's quite a few, right? Like, some of the stuff is like, people are not, I think like it's kind of going back to like Michael's problem, right? And the people connecting for the first time to V6 kind of question. Like a lot of the times the networks are not prepared for people doing stuff over V6. So people are starting to tunnel stuff over V6, and like, things just get through because the firewalls don't have any rules in them. Those kind of things happen quite a bit. And like, also stuff like V6 over V4, like, a lot of the content filters miss if you have a V6 tunneling protocol, like, could be like Teredo 624 or whatever, right? Like, which will take the package over V4, and then it doesn't meet any of your content filters for a lot of time. So, and those are some things. And the other part, like, on the flip side, people say like V6 is not secure because it doesn't have a NAT. And that's something that like kind of angers me quite a bit every time I hear it, right? So like the NAT happens to be a stateful firewall is really like an accident, right? Like you can do a stateful firewall in v6, of course, right? So I think once we like decouple these two, like I would say v6 is like just as secure as v4, like, and as Fred said, like due to simplified design, probably could be like even simpler, even more secure. Privacy wise, I think like key things like that can change is like, we have a lot more address space. So it's easier to do address rotations like in the network if you need to, right? And we have like privacy addresses, like, they're not like, what we thought they would be. Like previously, when you started off like doing IPv6, right? Like we picked all the addresses were made out of MAC addresses, right? You take the MAC addresses, split them into a bit and flip a bit, right? And we thought like, oh, like, people can identify a specific node across the internet by just following the MAC address piece of it. So we just made something more private, but like that doesn't give too much privacy if your prefix stays the same. So like, there's some kind of stuff there, like, we've done quite a bit of work, right? Like, we did this like DHCP v6 anonymity profile, right? Which actually talks about like, what you can do to kind of keep yourself anonymous, like, and MAC randomization. I think like, Michael is going to talk about, the other Michael is going to talk about the Medina stuff. Those are the kind of things that kind of play into the same v6 security space. But v6 having the extra bits make things like a little bit more secure. Like address scanning becomes harder in v6, right? In v4, I can exhaustively scan network space like very, very quickly. With v6, just finding the addresses that are populated is going to be very, very difficult. So there's certainly security advantages in v6.
Great, thank you. Thank you, Suresh and Fred. Okay, so next question. I think we're coming to the end here. So Jen, what would you say the lessons learned are from IPv6 deployment standardization?
Well, I hope we have another 3 hours, right? So I can keep talking. So, first of all, it will be more or less the same as with any other technology. I mean, start early, because unfortunately for v6, you probably will need to touch a lot of infrastructure. You might need to find that you need to replace or upgrade a lot of hardware or software. It would be a shame to find that you have just replaced it and it still doesn't have v6 because you didn't think about it. So yeah, if you want to get v6 like fully operational in 5 years' time, you probably need to start now. And do not trust vendors. Make be very explicit. I mean, if vendor tells you our equipment supports v6, it might mean nothing, right? So a lot of testing is required. But what is special for v6, I would say, you need to turn off IPv4 to really find out if your IPv6 is working. While you have dual stack, you don't operate in v6, you operate in dual stack. You operate in dual stack and happy eyeballs, and you might have a lot of hidden brokenness, which you don't know about or you couldn't easily find. And as soon as you start turning off v4, even temporarily, you'll find out a lot of interesting things. So that's very short summary, but yeah, I can talk for hours.
No, that's great. Yeah, I turned off. I did a v6 only test on my network a while back, so I totally know what you're saying. Yeah, no, lots and lots of fun. But Fred, what is your thought on this area? What about lessons learned?
Excuse me, I'm on mute. So I'm going to talk more about the standardization side. Now, IPv6 started being developed and standardized when I was the IETF chair, which is the latter half of the 1990s. And so I've contributed in various ways to IPv6 standardization, chaired a working group or two, done some different things. I wish that I had a penny for every author or every writer that would hear about some new feature and say, okay, so is IPv6 done now? Can we say that everybody turn off IPv4 and turn on IPv6? And the answer is, it's going to take more experience than that. And if you don't have enough experience to realize that, just shut up. I have become very frustrated with magazine columnists and so on that wanted things to be finished overnight. They don't get finished overnight. What we do is we put them out there, we learn about them, we fix them, and then we learn something else. So what have we learned? It's not to expect too much too soon.
No, sure. Yep. Mid-1990s, that's more than 25 years ago, practically. Yeah, time goes. Yep. Next question, or are we nearly at the? We should be getting close to the end here. Yep. You know, how much time do we have left? I think just maybe only like 5 or 6 minutes.
8 minutes to be exact.
People have been asking lots of questions. Let me see if there's anything. I think everything seems to be answered so far. Is there anything that anybody wants to ask? Go ahead and put it in the Q&A or send us a note. But otherwise, I think it certainly appears. I've only been glancing at the chat window. But it certainly appears there's been a lot of activity going on there. Yeah, thank you guys all. This has been super, super interesting. And we'll have to get Suresh and Jen to do webinars for INTC and IISOC. Yeah, because we've certainly had Fred talk for us. Drew, anything else that you can think of? We're going to start up again tomorrow evening. And I think there's a link if people want to stay afterwards and chat. I'm going to bed myself. It's late our time and much later for Suresh and Michael.
Yeah. What did you do? You woke me up. What are you saying?
There's a social. I mean, there's a link for people can socialize afterwards if they want to. But as I say,
Nalini, I wanted to ask a question. My closing remark is that this is such a great conference. Thanks to all of you for putting it on, and thanks for letting me be a part of it. And it's got me so fired up. I want to ask this question. Is there anything you can sort of whet our appetites with in terms of what IESOC and INTC might be doing next year?
Oh, you mean for the next conference? Or
conference, or any upcoming webinars or anything? I'm excited enough, but I want to be more.
Well, actually, we still have 4 more days. I mean, Michael is going to be talking about. There's so many great presentations. I really want to hear the Madina stuff, the MAC address randomization. I mean, I have a lot of actually. Anyway, I'm like, please don't do this to me. But that's a whole different story.
I'm excited for the rest of the conference too. I meant to frame my question in terms of IPv6 activities. Sorry.
Oh yeah. Well, we're going to be doing, as I said, we're going to be doing a call for enterprises to participate, and like we talked about in the morning, we want to start getting security profiles, application profiles built. And there's a couple, and I want to be a little careful about this, but there's already 2 different organizations who are talking to me about deployment templates and, how to help people going forth. And we hope to get more and more of those. Like if you're this kind of organization doing this kind of thing, it's not a one-size-fits-all, but the more help that we can give people, I think if we demystify it, and give people help and then say, you know what, we've got a team of folks that are going to be able to help you and it's not going to cost you an arm and a leg. Well, I think we might see, some people taking us up on it. Yeah, let's just see. But as I said, I really want to get folks at the IETF a lot more involved too, and having Jen and Suresh, coming into the V6 conversation is real good. Really going back and forth with what we're doing, what V6 Ops is doing. No, I think let's just go one step at a time. We've got to work together. That's all I can say. Yeah.
Sounds real good. Thank you.
Thanks.
Yeah. Thanks, you guys.
Thanks, Nalini.
Okay, Drew,
Thanks, Nalini. Thanks,
wrap
Dhruv.
up,
Thank you.
or-
Nope, we are good. Thanks, everyone. See you guys tomorrow, same time.
All right.
Yeah.
Yeah. Thank you,
Thanks all.
everybody.
See ya. Have a good night. See ya.
Bye, guys. Night.
Bye.